Welcome to this School Magic, where learning things together is magical. Heading on to the next question, question 27. So we got a ball, it's thrown vertically down towards the ground and rebounds and illustrated. So we have two diagrams. The first diagram looks like this. We have a ball and falls at 8.4 meters per second. This is point A, distance is 5 meters. Then we got another diagram where it rebounds, so you have the same ground level. The ball is here, and this is maximum height after rebound. Okay, let's check out the next sentence. Anything abstract. As the ball passes A, it has a speed of 8.4 meters per second, so already in diagram, so we don't have to worry about that. The height of A is 5 meters per ground, already shown in diagram, so we don't have to worry about that line as well. The ball hits the ground and rebounds to B. Okay, shown here. Assume that A resistance negligible. Negligible means we can use the UV sand technique. 1. Calculate the speed of the ball as it hits the ground. Okay. So this is A1. So as usual, let us draw our UV set line. U, initial velocity, final velocity, and starter rate. Remember, this is a vector question. Choose a direction positive to be downwards. U initially is 8.4 meters per second. Why does the object fall? Because it is pulled by gravity, therefore the acceleration of free fall here is positive g, and the s here is 5 meters. Therefore, we have three variables, means that we can actually find t or v. In this case, the question is asking us to find the final velocity. So you remember the 5 equations of motion? When using USA V, we don't need time. The fifth equation is the only equation that has no time. So the fifth equation we're using here, in this case, is V squared equal to U squared plus 2s. And U here, 8.4 squared plus 2, 9.81, and 5. Square root the whole thing, and you should get a value. Give you a few seconds to calculate while I check the value for you. You should get a value of around 12.99 meters per second. Notice at the beginning when you use this, it might be hard, but the more you use, the more you have a proper diagram. You notice this is actually quite an easy component of the course. So practice, and you should be okay. 2. Show the time taken for the ball to reach the ground is 0.47 seconds. Oh. So this is part 1. Now part 2. Good news, we can use the same diagram. This time, USA T. From the previous episode, you notice that this equation is equation 3. So it's S is equal to UT plus half AT squared. Whereas in this case is 5, U is 8.4 T plus half 9.81 T squared. I hope your math is okay. I hope you're able to solve that. So feel free to pause this video while you solve that. Once you got the answer, then you can unpause again. So the value we're looking at will be around T equal to 0.468 seconds. Now, nicely shown, we have the two values already. The next component will be, hopefully we can have enough space on the board. Part B, we have to fill up a graph. Let me change pen. So you have a graph that looks like this in the question. A V, a again, time graph, 0, so you have a positive quadrant and a negative quadrant. The ball rebounds vertically with a speed of 4.2 meters per second as it leaves the ground. So this one's given. So the speed as it goes up here will be 4.2 meters per second. The time the ball is in contact with the ground is 20 milliseconds. Be careful of this. You have a component here when the ball is between hitting the ground and rebounding. So an intermediate stage here. Intermediate stage, which lasts for around 20 milliseconds. The ball rebounds to maximum height h, as shown here, h. The ball passes A at time t equals 0. So label this h. It starts from t equals 0, so nothing special here. On the figure 27.2, plot graph to show the variation with time t of the velocity v of the ball. Continue the graph until the ball has rebounded from the ground and reaches B. Until it reaches point B. So we need the whole journey from here to here, intermediate stage, and then up again. So, good news is, direction is already taken, so you already chosen your direction to be positive in this direction. So you can start off, we begin at 8.4. So choose your scale correctly. You can say 8.4 is here. Remember, this is not drawn to scale. As you can see, this is not a grid graph. I'm just showing you how to do it. Then the next stage at the final velocity, we have it at 12.99. At time 0.468 seconds. So locate 0.468 seconds. Locate your 12.99. So you have a point here, so a point here, and it should look something like this. Then you got 20 milliseconds time interval. So what is 20 milliseconds in seconds? So let's just do a quick conversion. T equal to 20 milliseconds, milli is 10 to the minus 3. Therefore it is around 1, 2, 3. So around 0.020 seconds. Okay, 20 milliseconds. Minus 3. Minus 1, minus 2, minus 3. 20. Okay? So it's 0.02, so you have a time interval of 0.468 plus 0.020, 0.488. So there will be a stage here, 0.488, where you have to rebound stage. It starts at 4.2 meters per second. Recall again, positive in downward direction. So this 4.2 becomes negative. So let's say your minus 4.2 is here, which starts around here. So you can just connect it all the way down. Okay, it's a straight line. Remember, I'm not using a ruler. So just make sure that it's a straight line connecting this point to this point. And then it reaches maximum height. Question you have in mind, do you have to calculate what is the velocity at maximum height? Well, you know. What happens when an object is at maximum height? V goes to 0. Okay. But we have a problem. We know it goes here, but we're missing the time. So let's solve the time component. Let's draw another UV Saturday line. In this case, rebound is this direction. Let's take this to be positive. Remember, this is your choice, so don't worry. As long as the values here are correct, you start at positive 4.2 meters per second. UV, Saturday in between, V is equal to 0. We don't know what the height is. The height is actually h. A, careful, opposite direction to the pull of gravity, so acceleration becomes negative, and we just need to find time. We got 1, 2, 3. 3 information means we can solve this question. Now we have VEC2. Okay, we're not going to calculate this. So what equation uses the VEC2? Second equation motion. Definition of acceleration. What is it? It's A equal to V minus U over T, also known as delta V over delta T. We want to find time, so this interchange. T is equal to V minus U over A. V in this case is 0, minus U is 4.2, positive 4.2, A is negative 9.1. Notice as long as your direction is correct, the values will give the correct sign. Okay? Therefore, your time is still positive. So in this case, you guys can calculate now while I try to check what the time is in this case. Give you guys a few seconds to find out the time. Seems that you guys have to calculate this time. So let me do a rough check. It's 4.2, 9.81. Roughly, hopefully you guys will find the time. Let me call this time for rebound, time B. So make sure that this one is, this is TB, the value here. This is TB plus 0.488. Notice the difference. This is time calculated here. But in order to plot the graph, you need to add 0.488. Okay. And then it connects like this. I hope you understand this video. If not, please replay this video. Provide some feedback to me as well.